Hello everyone. My name is Dr. Aradhna Sahu, Associate Professor, Computer Science and Engineering Department from Shri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. Welcome to today's lecture on fascinating topic of steganography. In this video lecture, we will discuss the hiding data in images using Python programming. So, let us start the session. As the name suggested, image steganography refers to the process of hiding the data within an image file by embedding it into an audio, video, image or text file. It is one of the methods employed to protect secret or sensitive data from malicious attacks. So, the main purpose of steganography is to maintain secret communication between two peoples. It generally refers to encoding process, means hiding the data into file, and decoding means extracting the data from files. So, in this video lecture, we will understand encoding process, that is hiding the data in images using Python programming, and we will learn decode the data from an image file in my next video lecture, that is extracting the hidden data from images using Python. Before start the session, let's have a look to recap the working of steganography. In the computer memory unit, an image is represented as n cross m for grayscale images or m cross 3 for color images matrix, with each entry the representation and the intensity value of a pixel. The image steganography embeds a message into an image by changing the values of some pixel chosen by an encryption algorithm. Now we understand how is steganography done with the help of figure 1. The various terms used to describe the image steganography include: first, cover image. It is a unique color image file that can conceal the data. It is defined as original image. The next is text, which is shown in figure. Real data that you can mask within pictures. The message may be in the form of standard text or an image. The next is stego image. This is the image which is a hidden message. The steganography methods involves hiding a large amount of data, image, audio, text with a color bitmap images. In this study, the image will be filtered and segmented with bits replacement applied to the appropriate pixels. These pixels are chosen at random rather than in any particular order. Certainly, here are some important concepts and notes related to data hiding using steganography. The data is often converted to its binary representation bits for embedding. For text, each character is typically converted to its 8-bit binary representation. The most common method for hiding data in images is LSB embedding. It involves replacing the least significant bit of pixel values in the cover image with bits of the secret data. Smaller changes in LSBs are less likely to be noticed by human eye. The capacity of the cover image is maximum amount of data it can hide without being noticeably altered. The payload is the actual amount of data that is hidden. To retrieve the hidden data, some needs to know the method and the algorithm used for the embedding. So, extracting the data involves reverse process of reading of LSB of encoded image. The steganography is not an encryption, it's about concealing the data. Encryption can be combined with steganography for added the securities. The steganalysis is the process of detecting steganography. It involves statistical analysis and various detection techniques. We can use many tools and libraries to hiding data into files and extracting data from files. One of them is Python. The Python provides library like Pillow, OpenCV for image manipulation, which are commonly used in steganography projects. The use of steganography has both legal and ethical implications. It can be used for legitimate process, for example, protecting sensitive data, or for illegal activities, for example, hiding malwares. Always respect privacy laws and their guidelines when working with steganography. So, it has some steganographic challenges. While hiding data, too much data may result in noticeable changes in the cover image. Lossy compression format like JPEG can destroy hidden data. Robustness against steganography techniques. It is essential for secure steganography. We can go for advanced steganography method, which include encryption before embedding separate spectrum techniques and frequency domain method like DCT. We should always test our steganographic implementation to ensure that it effectively hides and retrieves data without noticeable degradation of the cover image. So, steganography finds application in various fields including cybersecurity, digital forensic, watermarking and secure communication. Let us start the learning of experimentation work of hiding the information into images. The steganography is the fascinating area of study. You can experiment with the different algorithms and the techniques to understand its capabilities and limitations better. The Python offers the several library and tools that make it possible to perform image steganography effectively. The image steganography involves embedding the secret data such as text or another image into an image in such a way that it remains visually indistinguishable to the human eye. The library files which we will use to implement for this work are Pillow, OpenCV and Stegano. The Pillow library files is a Python imaginary library files, and its successor Pillow provide the powerful image processing capabilities, making it possible to reload, load, manipulate and save the images in various file formats. The OpenCV is a open source computer vision library that can be used to manipulate the image including steganography. It provides functions for image processing, filtering, features extraction which can be useful in steganography techniques. Next, Stegano library. It is a Python library specially designed for image steganography. It offers tools to encode and decode the hidden message within images using various techniques such as LSB, least significant bit hiding. For this, we should follow a step-by-step approach of the hiding process with the help of Python programming. The steps for this approach are as follows. In the step 1, we import all the required Python library. The step 2, defining a function to convert any type of data into binary. We will use it to convert the secret data and pixel value into the binary in the encoding phrase. Then the step 3, defining the another function to hide a secret message in an image by changing LSB. Next is writing the another function that accepts the user image name and secret message and call the hide data function to encode the message. The next step, define the main method. There are some popular software tools and environments commonly used for Python implementation. The officially PyCharm, Visual Studio Code, Jupyter Notebook, Jupyter Lab, Spider and Colabs are. In this video lecture, we will implement data hiding algorithm using Colab. The Colab is a product from Google Research. It allows anybody to write and execute arbitrary Python code through the browser and is especially well suited to machine learning, data analysis and education. The more technically, Colab is a hosted Jupyter Notebook service that requires no setup to use while providing access free of charge to computing resources including GPU. It is really free to use. Type Google Colab into your search engine or directly visit Colab visited by going to colab.research.google.com. In the figure 2 shows the complete code for hiding data in images using Python. This is a Python code performs image steganography, which is the process of hiding a secret message within an image. Let's break the code into the smaller parts that we will able to understand each one by one easily. The code starts by importing the necessary library files which is shown in figure 3, including OpenCV, NumPy and some functions from the google.colab.patches library. These libraries are used for image manipulation and display. Use import keyword to call the libraries. So we write import cv2. This line imports the OpenCV library, which is a popular computer vision library used for image files. Then write import NumPy as NP. This line imports the NumPy library and assign it the alias NP. It is a fundamental library for numerical operations in Python. From google.colab.patches import cv2 underscore imshow. This line imports the cv2 underscore imshow function from the google.colab.patches module in a Google Colab environment displaying the images using OpenCV imshow mesh function may not work as expected. So cv2 underscore imshow is provided as a workaround to display images directly in the Colab notebook. After completing the import section, we are defining a function called message to bin having one parameter message as a argument, which is shown in figure 4. This function is defined to convert different types of input data like string, bytes and the array integers into binary format. The binary format is needed to hide the data within the image. These Python functions, message to bin takes an input message and converts it into a binary representation. The function handles various data types including string, bytes, NumPy, and the array integers and NumPy uint8 data types. Let's break down the body of functions and understand each part. The function begins with a conditional statement to check the type of message parameter. If the input message is the type string, the function converts each character in the string to its binary representation and concatenates them together. Let's see the for loop for it works. For I in message, these iterates over the each character in the input string. ORDI. These converts the character I into its Unicode code point integer value. The format ORDI 08B. These formats the integer value as an 8 character binary string with leading zeros if necessary. The join method, this concatenates all the binary strings for each character in the input string together. Next, if is the input message is of type byte or np.nd array, the function treats each element in the array as a byte and convert it to its binary representation. It returns a list of binary strings. If the input image is of type int or np.uint8, the function directly converts the integer to its binary representation as an 8 character string. If the input message is of any other type, the function raises an error, type error, with the image input type not supported. The figure 4 shows this function is used to hide the secret message within the image. It calculates the maximum number of bytes available for encoding within the image. It checks if the length of the secret message is greater than available space in the image and raises an error if so. A delimiter string hash is added to the secret message to indicate the end of the message. It treats through the image pixel by pixel, modifying the least significant bit of the each color channel RGB to encode the binary representation of the secret message. The loop continues until all the data is encoded or until it reaches at the end of image. The modified image is returned. Let us understand the detailed explanation of this function. The first, n bytes calculation. It is calculating the maximum number of bytes that can be used for encoding in the given image. It does this by manipulating the number of rows, number of columns, and third one is representing the R, G and blue channels of the RGB images and then dividing by 8 since there are 8 bits in a byte. This gives a total number of bytes available for encoding the image. Now check for the sufficient space. The code checks whether the length of the secret in bytes is greater than the calculated n bytes. If the message is too long to fit within the available space in the image, it raises a value error indicating that is significant space to hide the data. Then the secret message is concealed with the string delimiter hashes. This serves as a delimiter to indicate the end of the hidden message when it's later retrieved. The next method will do binary conversion. The function message to binary is called that convert the secret message into the binary format, which is already explained previously. Then the code includes the length of the binary representation of the secret message, bin secret message to keep record of how many bits needed to the hidden in the image. The code then iterates over the each pixel of the image. The each pixel is an RGB. Images consist of the RGB order. Now LSB modification has to be done for each pixel the code extracts from the binary representation of the red, green and blue values using the message to bin function. It then checks if there is still data in the bin secret message to be hidden. If there is a data to be hidden, it replaces the least significant bit LSB of each color RGB channel with a bit from the binary representation of the secret message. This is done by slicing the binary string and replacing the last bit with a bit from the secret message. The code increments data index to keep track the bits that have been hidden. Once all the data has been encoded into the image, or if the message is shorter than the available space, the loop breaks. Finally, the modified images with the hidden data is returned, which is shown in figure 5. The next function is encode text, which is shown in figure 6. This function handles the encoding process. Let us understand the body parts of this function one by one. The first line of this function is image underscore name equal to input and prompt. Enter the image name with extension. These first prompt to the user to enter the name of image file, including with the file extension. The image file will be used as the carrier of the hidden message. The next statement is img equal to cv2.imread method. Then the code reads the input image using OpenCV and stores it the image variable. The third line is print. The shape of image is image.shape. The next line is resize image equal to cv.resize method and cv.imshow for resizing the data. All these lines prints the shape of the input to calculate the number of bytes it contains and display the original image, then resize the image and then original image in the screen before encoding. Then we write data equal to input, enter data to be encoded. The code then prompts the user to enter the data text message they want to hide within the data, and it checks if the data entered in is empty. If it is, raise a value error because there is a no data to hide. The file name equal to input, enter the name of the new record image with extension. The user is prompted enter the name of the new encoded image, the image that will contain the hidden message along with the file extension. And the next line is encoded image equal to hide underscore data image comma data. It calls the hide data function to hide the provided data within the image. This is the key part of the code where data encoding takes place. The hide data function is responsible for modifying the image in a way that hides the data which is already explained. And at the last line of this function is cv2.imread method. Finally, this code saves the modified image with the hidden data to a file with the name provided by the users. The last method is steganography. The code of this method is shown in figure 7. The function is main function that allows the user to select whether they want to encode or decode the data. It prompts the user to choose an option 1 for encoding and 2 for decoding. If the user selects encoding, it calls the encoded text function. If the user selects decoding, which is not implemented code here because it will cover in our next video lecture. So it will call the decode text method. The code ends by calling the steganography function. Initially, the image steganography process based on the user's choice as shown in figure 7. Let's have a look the output screen using screenshot of the implemented code which is shown in figure 8. It will ask the option for encoding or decoding. So, we will choose option 1 to hide the data into images. After selecting the option 1, the details of original image will be appear on screen, which is shown in figure 9. The path of the original image is content folder of Google Colab online platform, which is the current working directory. We can see it on left pane and the name of file is selected by user. The code prompts the user for data which is to be stegan to image, like enter the data to be encoded. It gives the text area where we can input the data for hiding into messages, which is shown in figure 10, and then press the enter button for further processing. And then it will ask the name of encoded file and the path name with the extension. But before going to write the name, we first check the size of original file and it is 6.73K as shown in figure 11. And now enter the name of stego image. When we do enter the name of stego image, that is output.jpg, and press the enter key, after the some time the output file is stored in our current folder and can also check the size. After encoding process, it is 14.42K. The size is little bit increased due to some text has been injected on the output file, which is shown in figure 12. So, there are many more ways to hide the data in image files. For these, Python supports many steganography files like stegno. The steganography libraries are designed to facilitate the embedding and extraction of hidden data within digital files. They are often used for privacy security purpose to hide the sensitive information within multimedia files. This is the second complete code for the hiding the data as shown in figure 3. Let us understand each line of code one by one. So first, import the library files. From stegno import lsb and from pil import image. The stegno, this library provides functions for steganographic operation. Pil means Python image library. This is used for image processing operations. Defining the path to your input image and message you want to hide. In this code, the input image is named a1.png and the message is this is a and our secret message is this is a secret message. Now open the input image file using image.open function. Open hide the message in image using lsb steganography. The lsb.hide function from the stegno library takes two arguments, the image and the message. It returns a new image with the message hidden within it. Then we define the path of output steganographic image where you want to save the result using image.save method. It prints a successful indicating message that the message has been hidden in the output image. Just look at output of our implemented code. We can see that the original size of image, which is 72.51K in the left pane of the figure number 13, and the picture is the right pane of the figure 13. After running this code, you will get a new image named output_emg.png that appears usually identical to the original image but contains the hidden message within a LSBs as shown in figure 14. Now, its size is increased, that is 694.34K. The hidden message can be extracted using appropriate steganography techniques, as well as we can implement these code in the next video lecture. The output of steganography typically consists of an image or a multimedia file that appears to unaltered to the naked eyes but contains hidden information or a secret message. Finally, we can say that steganography is a practice of concealing the data within another medium, so protect it confidentially or to transmit it covertly. Here, what you can expect from the output of the code. First, image appearance. At first glance, the output image or a file will look like an ordinary, unchanged image or a media file. It retains its visual or auditory characteristics, making it indistinguishable from the originals. Then, hidden data. Beneath the surface of the output file, the hidden data is embedded. These data could be text, images, or other files. Next is security. The primary purpose of steganography is to enhance the security by hiding the data. Decoding. To extract the hidden data, a compatible steganography decoder is required. Applications. The steganography has various practical applications including secure communication, watermarking, digital right management, and forensic analysis. It can be used in contexts where privacy and integrity of the data are critical. I would like to summarizing the key points of hiding the data. Using Python, we can use libraries like OpenCV, Pillow, Stegno, and the various libraries for different types of media as well as image files. It has the various practical implementation in different domains, and we can implement steganography using Python in these areas: confidential messaging, password protection, digital watermarking, authentication, convert communication. That's. Keep in mind that successful steganography involves finding a balance between amount of data and visual impact on the cover image. If the changes are too significant, the steganography may be easily detectable. Conversely, if the changes are too subtle, the hidden data might be lost due to compression or image alteration. Remember, the steganography should be used responsibly and in compliance with applicable laws and ethical standards. It is a tool that can be used for both constructive and potentially harmful purpose. So, ethical considerations are paramount. It is also important to note that the field of steganography is vast and constantly evolving. The researchers are continually developing new techniques, and the effectiveness of any specific method can depend on the factors like sophistication of detection tools and the perceptual limitations of human senses. Thank you.